Energy generation due to interaction of two triboelectrical surfaces using effects Bernoulli Venturi and wind. There is an example of using a coating whose inner surface has triboelectric properties that hangs from a wall or panel with an external triboelectric coating. When wind gets between the wall and the coating, periodic fluttering of the coating occurs as sticking to the wall and moving away from the wall. There is an example of using two panels. One of the panels is located at an acute angle and the other one is attached on an axis to the top of the first panel. The second panel, rotating on an axis, can approach the first panel. There is a narrow space between the panels. When air passes through this narrow space, the Venturi effect is triggered. External pressure forces the panels to lean against each other. Then the force of gravity is triggered. The movable panel moves away from the panel located at an angle. There is an example of using several layers of pairs of triboelectric materials separated by elastic separators varying degrees of elasticity to carry out triboelectric interaction at different wind speeds. Several pairs of layers of triboelectric materials, each pair is separated by elastic materials of different degrees of elasticity as springs, polyurethane foam of different thickness. Bernoulli principle. Bernoulli's law establishes the relationship between the velocity of a stationary fluid flow and its pressure. According to this law, if the fluid pressure increases along the flow line, the flow velocity decreases, and vice versa. Thus, when the airflow passes through the narrowed part of the pipe, the flow rate increases. This can be used for a wind turbine placed in a pipe. The Venturi effect is a pressure drop when a stream of liquid or gas flows through a narrowed part of the pipe. The pressure drop can be used for triboelectric pressure separation interaction. Triboelectricity, triboelectric pairs, triboelectric interaction. There are materials that are capable of giving and receiving charges when interacting with each other. Such materials are arranged in a triboelectric series. An example of a triboelectric series is shown in the figure. Among triboelectric materials, it is possible to distinguish separate pairs of materials that, when interacting with each other, exchange electric charges. There are two types of triboelectrical interaction: pressure separation and friction. In such interaction, electrons pass from the donor material to the acceptor material. Similarly, processes occur when one material is rubbed against another. Everyone has seen cloth fluttering in the wind before. Often, when the walls of houses are covered with a protective film during repairs in order to protect them from dust, it can be observed that with a slight wind, the protective fabric periodically leans against the wall of the house, and then moves away from the wall. This is the fluttering of the film due to the pressure drop due to the Venturi effect. Studies have shown that similar fluttering processes using triboelectric materials can be used to generate electrical energy. We offer our own option for scaling up the production of electric energy in this way. The wall or panel is covered with several groups of layers of materials forming a triboelectric pair. Each group is isolated from the other and isolated from the external environment and from moisture and dust. Elastic materials are laid between triboelectric pairs, which do not allow the materials from the pair to come into direct contact. Fluttering is a source of pressure drop. Elastic materials restore the separation of triboelectric materials in a pair after the pressure disappears. More detailed information can be found in the patent description. Wall and coating condition. A coating due to the fact that the size of the coating is larger than the wall to be coated, the coating moves away from the wall, and an air stream penetrates into the space between the coating and the wall. The condition of the wall and the coating. The airflow passes between the wall and the coating. Due to Bernoulli's law and the Venturi effect, the external pressure on the coating increases and the coating is pressed tightly against the wall. A triboelectric interaction phase pressure occurs. The condition of the wall and the coating. The airflow does not pass between the wall and the coating. The coating moves away from the wall. A phase of triboelectric interaction separation occurs. Two panels, one at an angle and the other on an axis. Two panels are used, one fixed at an acute angle, the other movable on an axis mounted on the top of the first panel. The second panel can be directly adjacent to the first panel under the influence of a pressure drop from the outside and inside of this panel. The pressure drops in the narrow part between the first and second panels, while the external pressure remains unchanged. The pressure drop is caused by the Venturi effect. Under the influence of the pressure drop, the movable panel is adjacent to the fixed panel. The narrow space between the first and second panels closes. Under the influence of gravity, the movable panel assumes an upright position. This process is repeated periodically. The case of a multi-section model: 2 panels, one at an angle and the others on an axis. 2 panels are used, one fixed at an acute angle, the other movable on an axis mounted on the top of the first panel. The second panel has several sections located on the axis and can be directly adjacent to the first panel under the influence of pressure drop from the outside and inside of this panel. Under the influence of a pressure drop, parts of the movable panel may become adjacent to the fixed panel. The narrow space between the first and second panels can be partially closed. Then, under the influence of gravity, parts of the second panel can move away from the first panel and assume an upright position. The whole process of attaching the panels to each other and then separating is shown here. This process is shown for both a single-section movable panel and a multi-section hinge panel. Several pairs of layers of triboelectric materials, each pair is separated by elastic materials of different degrees of elasticity, springs, polyurethane foam of different thickness. A multilayer structure is used to generate electric current. The device is a sandwich consisting of several layers. Materials that make up triboelectric pairs, as well as materials used as a conductive medium, are used as layers. A bumpy, elastic material is located between the materials that make up the triboelectric pair. In each layer, the height of the mounts defined for this layer will be used. Layers of triboelectric materials are placed in the panel. The panel is positioned as if on one side of the panel there is a small space for air to pass through, and on the other side there is nothing to limit the space for air to pass through. The proposed panel device will generate electrical energy when there is a pressure drop on different sides of the panel. This is possible if the Venturi effect is triggered. The proposed device for generating electrical energy can be located in places where it is possible to create a pressure drop due to the narrowing of the space for air to pass under the panel. Such places include roofs of houses, roofs of moving vehicles, places on roads in the immediate vicinity of moving cars in case of heavy traffic. For example, on highways in the USA. A patent has been obtained in Germany for such devices for generating electrical energy using energy, the Venturi effect and triboelectric interaction. The German Patent Office conducted an examination for novelty and potential for commercial production and issued certificate. A detailed description can be found on the website of the German Patent Office. Thanks for your attention.